exploring unknown tech, decoding future unicorns. Welcome to Product X, where we use the sharp intuition of capital and the hardcore logic of an architect to help you catch the next big thing in global tech. I'm Rena, your host. Today we're diving into a fascinating space tech story. Dayton, Ohio-based startup Ravee Optics just closed an oversubscribed $6 million seed round led by big capital, with participation from Jobs Ohio and Cincy Tech. Founded by two veteran scientists from the Air Force Research Laboratory, they're building miniature optical communication terminals that let satellites talk to each other using lasers, claiming to boost data transmission throughput by 10x to 100x. Vivian, want to kick us off?
Hey Rena, thanks for having me. I'm Vivian, a senior angel investor at Pre-Angel Fund, and I've been tracking the space economy for over a decade now. Super excited to dig into this one because what Ravee's doing represents a major shift in how we think about orbital infrastructure.
Nolan, your turn.
Hi Rena, hi Vivian. I'm Nolan, a former Silicon Valley big tech CTO and systems architect. Been building high-scale distributed systems for years, and honestly, the engineering challenges these folks are tackling in free space optics are exactly the kind of hard problems I love getting into.
So, here's the puzzle. In the space track right now, everyone's investing in reusable rockets, or LEO IoT constellations. Why are top-tier space VCs rushing to lead a round in a hardware company building what amounts to inter-satellite fiber optics? What shift is happening in the underlying commercial narrative? Vivian.
The investment logic of the space economy has officially entered its second phase. Over the past decade, companies like SpaceX slashed the cost of sending a kilogram to orbit by 90%, solving the problem of how to get up there. But now we have thousands of satellites crowding LEO, and the traditional RF spectrum is completely saturated. It's like we've built a massive highway system but only have a 2-lane road for data. Capital is realizing that the real bottleneck now isn't launch costs, it's orbital data throughput. Ravee's laser terminals address exactly that, and they come with a dual-use model that lets them tap defense budgets early while positioning for massive commercial scale later.
Yeah, and from a technical standpoint, what they're solving is brutally hard. You've got two satellites screaming through orbit at 7 to 8 kilometers per second, separated by hundreds of kilometers, and they need to hit each other with a laser beam just a few millimeters wide. That's what engineers call the PAT problem pointing: acquisition and tracking. Traditional OISL terminals weigh tens of kilograms and cost millions, but Ravee's figured out how to shrink that down using integrated photonics and inertialess beam steering. No mechanical gimbals, just fast steering mirrors and closed-loop control algorithms that can react in milliseconds.
Okay, so let's unpack that. Nolan, you mentioned shrinking the hardware. How small are we talking? And why does that matter for commercial viability?
We're talking terminal size comparable to a standard cable set top box, not those massive bespoke units that used to require a dedicated payload. The key is their photonic integrated circuits. They've put transmitters, modulators, and detectors all onto a single wafer-level chip. That dramatically reduces size, weight, power, and cost. For commercial constellations trying to deploy thousands of satellites, you can't afford multi-100-kilogram communication payloads. This approach makes it feasible.
And that's exactly why this becomes a $100 billion monopoly play. Once Ravee establishes their terminals as the standard for commercial LEO constellations, you've got a hardware moat that requires massive R&D to replicate. Plus, there's recurring replacement demand. Satellites don't last forever, and neither do optical components in harsh space environments.
Vivian, you brought up the dual-use model. Can you expand on that? How does leveraging defense contracts actually help a company like this scale commercially?
The beauty of the U.S. aerospace dual-use model is that early-stage revenue comes from defense contracts with the Space Development Agency and AFRL, which provides non-dilutive cash flow to validate the technology without burning through equity. Then, as commercial orbital data centers from tech giants scale up, Ravee can sell into that market with a mature, proven product. It's basically using Pentagon budgets to hone the tech, then harvesting excess profits from commercial players who need that infrastructure now.
I'd push back a little on the timing, though. The commercial orbital data center play is still nascent. We're talking 2026, and most of these initiatives are still in the validation phase. The real revenue driver in the near term is still government contracts. But the upside is undeniable. Once commercial demand kicks in, the margins could be substantially higher.
That's fair, Nolan. I agree the timeline is earlier on defense, But the market sizing for commercial is what gets investors excited. The AI compute demand driving this is exponential, and ground-based data centers are hitting power and cooling limits. LEO offers 24/7 solar and natural heat dissipation. The data backhaul problem has to be solved, and laser comms is the only game in town.
Let's talk about the manufacturing angle. I've seen claims that Ravee is designed for automotive-grade mass production. What does that actually mean in the context of aerospace hardware?
Historically, when NASA or military contractors built laser terminals, it was a handcrafted, lab-based process, 1 unit per year, millions of dollars per copy. Ravee's approach from day one was designed for manufacturing. They're using standard semiconductor fabrication processes, integrated photonics, and automated assembly techniques that borrow heavily from automotive electronics. That means they can produce thousands of units with consistent quality and dramatically lower unit costs. It's a completely different paradigm from the legacy aerospace supply chain.
And that's the real moat. Anyone can try to replicate the technology, but replicating an entire manufacturing ecosystem is much harder. Plus, once you're embedded in the supply chains of major constellation operators, the replacement and upgrade cycle keeps you relevant for decades.
So what happens next? Where does this technology fit in the broader orbital mesh network that everyone's talking about?
The next frontier is inter-satellite mesh routing. Current laser links are mostly point-to-point, but to support space-based AI data centers, you need a dynamic mesh network where thousands of satellites can reroute traffic in real time. When a satellite goes into eclipse or experiences thermal issues, the network needs to autonomously reconfigure. That's where the software and edge algorithms become just as important as the hardware itself.
And whoever owns that routing layer essentially becomes the Cisco or Huawei of the orbital AI era. That's the Vision laser terminals as the fundamental infrastructure layer for next-generation space computing.
Absolutely fascinating. Let's shift gears into our lightning round. Quick-fire questions give me the first thing that comes to mind. First question. Biggest misconception about the space communication industry?
That it's all about rockets and satellites. The real money and innovation are shifting to the infrastructure layer.
That laser comms is a solved problem. It's not, there's still massive R&D needed on the networking side.
If you could teleport one piece of current tech into 2026 space, what would it be?
Advanced AI-powered beam steering. That would accelerate everything by years.
Cheap. Reliable quantum key distribution integrated into these laser terminals. Game changer for secure orbital communications.
Biggest risk factor for Ravee's growth?
Supply chain dependency. Photonic integrated circuits require specialized foundries, and that's a bottleneck you can't just scale overnight.
Competition from big defense primes who decide to go commercial. Lockheed or Northrop could wake up and decide to play in this space.
Most underrated player in the orbital data center race?
The Chinese. They're moving fast on laser comms and have a different regulatory environment that lets them iterate faster.
Actually, I'll say the regional operators, smaller players in Japan, India, and Europe who are building niche LEO constellations. They could become meaningful customers faster than the bi-hyperscalers.
Love it. Now let's wrap up. Vivian, give us a one-sentence summary of today's topic.
Ravee Optics is building the foundational optical infrastructure that will unlock the next era of orbital AI compute, turning the bottleneck of inter-satellite communications into a strategic moat.
Nolan.
Their photonic integration and design for manufacturing approach makes laser communications commercially viable at scale, which is the key enabler for any real orbital data center future.
That's a wrap. Through Vivian's capital analysis and Nolan's technical breakdown, we can see that what Ravee Optics is doing is laying the critical infrastructure for the impending explosion of low Earth orbit computing. When AI compute goes orbital, the medium of transmission defines the boundaries of intelligence. In the vacuum of space, without the connection of light, there can be no true orbital intelligence. Thanks for tuning in to Product X. See you tomorrow.